Okay, welcome, ladies and gentlemen, to our last section, our last new section from Chapter 5. We're going to be dealing with what's called the quadratic formula. And essentially what it is, it's a way to solve quadratic equations that don't factor. So what we're going to start with is just a refresher on what it meant to solve a quadratic equation that could factor. So given the x squared plus 5x plus 6 equals to 0, we could factor this problem to x plus 3 times x plus 2. And then knowing that x plus 3 equals 0, we could say that x is negative 3. And then we could say that x is also negative 2. Now that gets our two answers to our quadratic equation. And we expect two answers because quadratics will factor to two different factors, or some of them do. However, not all quadratics factor. So what happens if you get a quadratic here that doesn't factor? There are no two numbers that will multiply together to get 9, but will add together to get 7. There's no possible solutions to this. So if the problem doesn't factor, or if you cannot factor quickly, we're going to use the quadratic formula. Now, in a quadratic equation, you expect to have two answers. So there is a way to solve this, and using a little bit of algebra that we're not going to cover in this lesson, we create the quadratic formula. The quadratic formula comes actually from basic algebra, solving this equation in a very, not tricky way, but kind of a trick kind of way of solving this equations without factoring. And what we get is a very, what mathematicians would say, very beautiful formula. This is a very simple formula. This is very useful formula. It's an extremely important formula in the study of mathematics. And it's one that needs to be memorized. So to help memorize this formula, we sing a song. And we sing a song in the tune to Pop Goes the Weasel. So here goes nothing. We start with x equals, and we say the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. All right, that is the song. If you want to hear it again, you rewind and you listen to it again. I don't do that song very often, but the variables here, the a, b, and c, come from the standard form equation. And it must be in standard form before you can use this. So it has to look like ax squared plus bx plus c equals 0. Now, when we get a formula like this, where we get b's, a's, and c's, something like this, that means it will work on every single quadratic equation. And it actually will work on every single quadratic equation, whether you could factor it or not. So when you're looking at a problem, let's say this first example. Now, technically, this first example will factor. However, let's say you couldn't factor it quickly. So what we do is the quadratic formula. So the quadratic formula, as we mentioned on the last page there, is some big formula that uses a, b, and c. So first of all, we have to look, is this in standard form? The answer is yes, because it's ax squared plus bx plus c equals 0. So I want to pick that out. I want to say that a is equal to 3, b is equal to negative 5, and c is negative 2. So then we're going to say x is equal to the opposite of b plus or minus. That plus or minus means it's this thing plus the radical and this thing minus the radical. It means I have two answers. And I have the square root of b squared, negative 5 squared, minus 4 times a times c all over 2 times a. So then we need to simplify. We need to simplify all of this stuff down. So we get negative 5, which is positive 5. We get plus or minus the square root of 5 squared, which is 25. Be very careful here with the negatives. This is actually a negative 4 times 3 times negative 2, so it makes a plus 24 all over 6. Here we get 5 plus or minus the square root of 49. Well, that's a nice number. All over 6. And so what this means is I have 5 plus or minus 7, because the square root of 49 is 7, over 6. Now, recall from the last lesson, we know how to simplify square roots, and we know how to simplify square roots if they include a negative, because we can have the imaginary answer. Now, in this statement, we have 5 plus or minus 7, which means we have 5 plus 7 over 6, and we have 5 minus 7 over 6. Well, 5 plus 7 is 12, divided by 6 is 2. And 5 minus 7 is negative 2 over 6, which is equal to negative 1 over 3. And there we get two answers to our quadratic equation. So as long as you follow the steps here, this is actually a very simplistic formula. It's very, very useful. Let's try another one here. So here we have 3x squared minus x equals 4. So we're going to start the same way. We have to make sure that it is in standard form, and it's not. So we have to subtract 4 from both sides. So we get 3x squared minus x minus 4 is equal to 0. So we got our new statement there. Then I'm going to pick out a is 3, b is negative 1, and c is negative 4. So then we say, okay, x equals, using the quadratic formula, we say x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. And then we do as we did before. We simplify this big formula down. Negative 1 makes a plus 1. Plus or minus the square root of negative 1 squared is 1. 4 times 3 is 12 times 4 is 48. So I get plus 48. Oh, look, I get the same number again. Over 6. This becomes 1 plus or minus the square root of 49 over 6. And if I do the split now, I get 1 plus square root of 49, which was 7 as we found earlier. 1 plus 7 is 8. And 8 over 6 is the same thing as 4 over 3, and just leave it as improper. And we also have 1 minus 7 over 6, which is negative 6 over 6, which is negative 1. And there you get your two answers. Our last example is this one. It's a very important example because it deals with the imaginary number. So again, put this in standard form. If I add 6x to both sides, that means I get plus 6x. And if I add 7, I get plus 7 equals to 0. All right, so again, we're going to do the same kind of thing. We're just going to point these things out. We have a is equal to 3. Sorry, not 3. A is equal to 2. B equals 6. C equals 7. All right, so we go x equals the opposite of b. So opposite of 6 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Simplify. Negative 6 plus or minus x 6 squared is 36. 4 times 2 is 8 times 7 is 56. Simplify a little bit more. We get negative 6 plus or minus the square root of negative 20 all over 4. So we need to do that little scratch work stuff that we did from the last lesson. We know that the square root of negative 20 is equal to the square root of negative 1 times the square root of 4 times the square root of 5. And the reason I use 4 is because it's a perfect square. So I get 4, square root of 4 is 2, square root of negative 1 is I, and the square root of 5 stays the square root of 5. So that means back here we get negative 6 plus or minus negative 6 plus or minus 2i radical 5 all over 4. And because we can't simplify this down to a very nice number, we're going to leave this as a plus and minus. However, one thing we can notice is that this 6, this 2, and this 4 are all even. And if all of those things have the same number, I can cancel out a 2. So this becomes a 2, divide that by 2, I divide that by 2, and I divide that by 2. And I get a final answer of negative 3 plus or minus 1, if you want to write it, I radical 5 all over 2. And there we get two answers. We get negative 3 plus I root 5 and negative 3 minus I root 5 over 2 on both of those. Okay, so the one thing I kind of mentioned right there really quickly is if I have a 4 plus or minus 8 radical 2 over 4. Something that I can do here is I can simplify this because the 4 has to go to both things. The denominator has to go to both of these. So this becomes 4 over 4 plus or minus 8 radicals 2 over 4. And the 4 over 4 becomes 1. And the 8 over 4 becomes 2. So that's why I can come back here and without needing to do the split, I can just cancel the 4 to a 1. It goes into the 8 twice, and it goes into the 4 once. And that's why I get the 1 plus or minus 2 radical 2. All right, so that's very useful to know. That's the end of the video. That's the end of chapter 5. Please figure out what we're doing here. This is very, very important so we can move on into our study of polynomial functions. All right, I will see you guys tomorrow. Have a good one.